Okay, we are on page 4 in our Choose a Function Model review packet here. And today we're going to talk about point slope form. So last time we talked about slope intercept. Today we're going to talk about point slope. Again, there is a third equation format that I can use for representing linear equations, that standard form. We won't use that so much moving forward in your next algebra class. So I just want to focus on slope intercept, which we talked about last time, and now point slope. So point slope form for a linear function tells us a point from the line, any point at all, and the slope of that line. They were not in any way trying to be tricky when they named this. Point slope form, what does it tell me? A point and the slope, okay? It looks like this. Y equals m times x minus x1 plus y1. Just like with our slope intercept form, m represents our slope. And then this x1, y1 here, those are the individual pieces of a point on the line. And those are pieces from a point on the line. So x1 comma y1 is a point from our line. Okay. And remember, points are always in that x comma y form. So that first number is always going to go in with x. That second number will be our y value at the end. The only tricky part here is that as we saw when we talked about quadratics and vertex form or factored form, as we saw with a lot of our transformations, when I have something grouped in with x, like we do here for our point slope, we've got this x coordinate grouped in here with x. When I actually translate to the graph, the sign will be opposite. So if I see x minus 2, that actually would be a positive 2 when I talk about the coordinate. So we're going to graph some equations in point slope form. We want to start by identifying a point on that graph. For slope intercept form, we started by plotting a point, and then we used the slope to find more points. We're going to do the same thing here, except for the point we know won't necessarily be the y-intercept. So if I take a look at A, I'm going to pull out my point. That would be 1, 2. Again, opposite sign here from what I see in parentheses. I'm going to start by plotting that point, 1, 2. And then my slope here, 3. Just going to jot down my over 1 there so I can see the rise and the run. I use that slope to get more points on the line. I'm going to start from this guy. I'm going to go up 1, 2, 3 and forward 1. Up 1, 2, 3, forward 1. And then I'm going to run out of space that way. So now I'll reverse my direction to find more points to the left of where I started. 1, 2, 3 down and back 1. 1, 2, 3, 1. 1, 2, 3 over 1. 1, 2, 3 back 1. Remember, when you're graphing a line, your points are self-checking. Okay? As I'm plotting these points, they should all fall in a straight line. If I have a weird jog at some point, that means I should probably go back and double check that slope between whatever points line up and whatever points don't. Okay? If I get a weird kind of goofy thing that happens in the middle of my line, go double check your slope. Once I filled my coordinate plane, connect your points, throw your arrows on the end. Okay, here's the graph of our line. For B, same idea. I'm going to start by identifying my point. This would be -3, comma, -1. I'm going to start by plotting that. 1, 2, 3, and then down 1. My slope this time is 1/2, so up 1, forward 2. From my point that I plotted, up 1, forward 2. Up 1, forward 2, and I keep going until I reach the edge of my coordinate plane. Up 1, forward 2, up 1, forward 2. And then I reverse those directions from my slope to find points to the left of where I started. So down 1 and back 2. Down 1 and back 2. Down 1 and back 2. Keep going again until you filled your coordinate plane. And then sketch your line through your points. Put your arrows on the end. Questions for me so far? Okay, let's hop down to C. Again, I want to start by identifying my point from point slope form. So this would be -2, 2. I'm going to plot that first, -2, 2. And my slope is -1/3 here. So that means I'm going down 1, forward 3. We talked about this last time with our slope. The rise could be up or down, but we always move forward. So this tells me down 1, forward 1, 2, 3, down 1, forward 1, 2, 3, down 1, forward 1, 2, 3, down 1, 1, 2, 3. And now I reverse those directions to find points to the left. So up 1, back 1, 2, 3, up 1, back 1, 2, 3. And I'm going to run out of room if I try and do another one. So we'll stop there. Again, my points should all line up. If they don't, go back and double check what you plotted. Throw your arrows on the end. I would like you to try D now. We want to start by identifying our point from our function. That would be 2, -3. I'm going to plot that. 2, 1, 2, 3. And then my slope is -4. So I'm going to write that as -4/1 again so I can see the rise and run. So this tells me I go down 4, 1, 2, 3, 4, and forward 1. 1, 2, 3, 4, forward 1. Just off the graph on that last one. And then reverse my directions. 1, 2, 3, 4, back 1, up 1, 2, 3, 4, back 1, 1, 2, 3, 4, back 1. Once you've got your points plotted and you've filled your coordinate plane, go ahead and connect your points. Throw your arrows on the end. Questions for me graphing from point slope form? Okay, the next thing that we're going to look at is writing the equation of a line using our point slope form. So what if I can't see the y-intercept? When we talked about using slope-intercept form, we identified the y-intercept from our graph and the slope. You might not always be able to clearly identify the y-intercept. So we're going to take a look at another option that we have, okay? Point slope form. So I'm going to write an equation for each of these lines in point slope form. So I'm going to start by identifying, we'll find 2 points on our line because we need to find the slope between our points. So for A, I've got a point here and a point here. If I count my slope between them, I'm going always from left to right. So I would have to go down 1, 2, 3, 4, 5. That'd be -5. And over 1, 2, 3, 4. So my slope is -5/4. And then I have 2 points to choose from. So I'm going to write both equations. Remember, for point slope form, you can pick any point that's on your line. So we'll write 2 equations for this first one. So this point here is 0, 5. The other point I have is 4, 0. So I've got the y-intercept and the x-intercept here. If I were to write an equation using 0, 5, that would look like y equals -5/4 times x minus 0. So that's my x coordinate, plus 5. So that's my y coordinate. If I wanted to use the other point instead, I would get y equals -5/4 times x minus 4, remember opposite sign from what I see here, plus 0. Okay, I can write this based on any point from my line. Questions for me so far? Okay, for B, I've got 3 different points that we can identify from the portion of the graph that I've got here. So I'm going to start by finding my slope by counting between 2 of those points. So if I go from the leftmost to the next nice point, I would have to go up 1 and then over 1, 2, 3, 4, 5. So 1/5 is my slope there. And let's go ahead and write it based on this leftmost point. So that would be the point -5, -1. Again, I could write this based on any points that I can identify on my graph. I'm just choosing to write it based on this leftmost point. So my point slope form equation would be y equals 1/5 times x plus 5, remember opposite sign, minus 1. Let's hop down to C. Again, I need to identify a couple of points on my graph so that I can find the slope. So I've got 2 nice points there. My slope, if I count between them, always going from left to right, would be up 1, 2, 3, 4, 5, 6, 7, 8, and then over 1, 2, 3. And then I've got, again, just 2 points here, so I'll write my equation, or I'll write 2 equations, I should say, based on each of these. The leftmost point would be -3, 1, 2, 3, 4, -4. Over here, we've got the point 0, 1, 2, 3, 4, 0, 4. So my 2 possible equations, based on what I can see here, would be y equals 8/3 times x plus 3 minus 4, or y equals 8/3 times x minus 0 plus 4. If I had more easily identifiable points on my graph, I could write more equations. Okay, doesn't matter which point you choose. If we had, let's say, this point labeled for us, and it said this is the point -1, 1 point, maybe 2, 8, even though that's not a nice point, if I knew the coordinates of it, I could still use that to write point slope form. Okay, doesn't matter which point as long as it's on the line. And finally, D, I'm going to pick, as we go from left to right, the first 2 points that we see to find my slope. So this would take me down 2 and forward 1, 2, 3. So my slope is -2/3. This first point here is -3, 4. So I'll write my equation based on that one. This would be y equals -2/3 times x plus 3 plus 4. Now we do have 2 other nice points on the graph for D. I would like you please to write me another point slope form equation based on either of the 2 remaining points. So we did this one together. I want you to write an equation now based on this point or this point. You pick. But I want it in point slope form. you should have one of these two equations. So if you use the y-intercept, that would be this equation here. If you use the x-intercept, that would be this equation on the bottom. Questions for me? Okay. The one last thing I want to point out. These graphs look familiar to you guys? They should have. We used them yesterday. Okay. So if I flip back in my packet and do a little comparison here, I want you to notice something. If I take a look at equation 2, or I should say graph 2, okay? We wrote two different equations for graph 2, but if I look at the top one, that was written based on the y-intercept, right? That 0.5, 0 was my y-intercept. And so in parentheses, I have x minus 0. Well, if I'm subtracting 0, we don't actually need to write that part. So if I omit that, I have exactly the same equation that we wrote yesterday in slope-intercept form. Okay, same thing. And then our y-intercept for b is at the origin, right? It's at 0, 0. So I could have also written y equals 1/5 times x minus 0 plus 0. But when I'm adding and subtracting 0, I don't actually have to write that piece. So I could have just written y equals 1/5 x, which is what we had yesterday when we wrote this based on slope-intercept form. Now, I want to show you something. I didn't write my equation for b based on that y-intercept, which was at the origin. I wrote it on a different point. However, the reason that we can pick any point we want, and it's going to match our line, and we can have several equations that describe the same line. If I were to treat this as a problem that I needed to simplify and distribute that 1/5 in, I would end up with y equals 1/5 x. And then 1/5 times 5 is just 1. And then I've got this minus 1 here. So I would have y equals 1/5 x. And then add 1, subtract 1, and that's just 0, which is the same thing that we would have gotten had we written slope-intercept form. So if I were to distribute that slope and combine my like terms, no matter which version of my equation that I've written, I'm going to end up with the same thing. That's why it doesn't matter which point we use. And we see the same thing for C when we wrote it based on the y-intercept, right? I can omit that minus 0, and I would just have slope-intercept form. And the same thing for D down here. If we wrote our equation based on the y-intercept, I would have slope-intercept form. Same idea. Questions for me for today? Okay, so that's point slope form. We do have a couple more topics. We're going to talk about with linear functions. Again, we're not going to look at graphing from standard form because that's not something you guys will use so much in Algebra 2, but the point slope form versions of a linear equation will pop up every now and then.